after the midterm, so we need to prepare for the final. Yeah. So there are some, still we have several assignments we need to, do it, several assignments. Yeah. But we do not have a lot of time before the final, just about 1 month. Yeah. So 1 month. And if we look at the assignments we have to do something special. Yeah, because in this 1 month period, we cannot do too many assignments. So we have to, control the reasonable amount of coursework. Yeah, so I have to do that. So my plan is like this. Yeah. So now we have 3 quizzes, right? Yeah. So the remaining assignment, we have 3 quizzes. Yeah. 4, 5, 6, right? Yeah. 4, 5, right? We don't. Yeah. So I remember 4, 5. Yeah. 4, 5, or 6. Yeah. Yeah. Actually, yeah. So I will look at the syllabus. 5 or if we have 6 or not. Yeah. Yeah. And homework assignment number 2 and number 3. Yeah. And project number 2. Then final. So you can see quite a lot. Yeah. But I plan to do this way. Yeah. So we combine. Yeah. Combine. In this way, we can reduce 2 assignments. Yeah. So what's the meaning of combine? Yeah. All right. The meaning is our next assignment, quiz number 4 equals homework assignment 2, part A, 2A, 2B. Yeah. 2A, 10 questions. Yeah. I just post as quiz number 4. So you work on our usual quiz number 4. But after you complete it, I just use it, also counted as part A of homework assignment number 2. Yeah. So in this way, we combine the work. Yeah. So reduce your work a little bit. Yeah. So then homework 2, part B, 15 query questions, because we want to practice SQL query questions. Yeah. Okay, that's homework assignment. Then for homework assignment 3, we will do the same way. Okay, homework assignment number 5, right? Yeah. So quiz number 5 equals homework assignment 3A, 10 questions. All right. Yeah. So then homework assignment 3, part B, 15 query questions. All right. Yeah. So in this way, yeah, after the combination, so you can do less amount of work. Yeah. So we can reduce at about two quizzes, right? Yeah, 2 quizzes. Yeah. All right, so then final project to, still a lot of work, but we do slightly less. So that's the plan. Okay. All right. Yeah. So today we do module 5, complex queries and indexing. First, we study the complex queries. All right. 8.1, correlated nested queries. All right, so after today's class, then we can do homework assignment 2B. So 2A as a quiz, okay? 2B, a query part. All right. First, what is the correlated nested queries? Actually, in our previous a few questions, actually you already, so you did one or two correlated nested queries. So remember when you use the in operator, right? Some questions when you use the in operator, that's the nested query. Here, let me give you the definition. What's that? Whenever a condition in the where clause of a nested query references some attribute of a relation declared in the outer query. So you have an outer query. Okay. For example, I remember we have a question about employee and a dependent, right? In our company database. So we have employee table and a dependent table. And we want to look at, if an employee has a son or has a daughter, so when we do that query, there is a way to write the query statement as nested, correlated nested query. So what's that? So we have outer query, then inner query. The outer query, that's this employee table. It's in outer query. Select first name, last name of employee, outer query. Okay. Where? So that where is the inner query. Where SSN in operator, in. Then parenthesis, you have another query, select ESSN, from the dependent table. So that one. Okay? So let me use the space here to write that query. Outer query select first name, last name from employee. All right, Then the where clause. When you write a where clause, for example, here we want to look at, so if this employee has a dependent son or not. So we want to retrieve those employees who have a son. Right? So then, one way to write SSN, this employee SSN, in, then inner query, parenthesis, this is inner query, okay? Inner query select ESSN from dependent table. Right? Where in this inner query where clause, okay? it has a sum, right? So it has a sum, so relationship. Equal sum. Yeah. So this gives it, those employees who have a sum. Yeah. So this is a nested, correlated query. Yeah. So with this structure, so you can write many queries in this way. Yeah. Yeah. All right. Yeah. So this is, later we can have many questions. We can use this way to write. Yeah. All right. Understand correlated queries. How to understand? So you need to, understand the structure of this query. Yeah. You can understand a correlated query better by considering that the nested query is evaluated once. Yeah. So here, the structure pretty much like the nested for loops, right? Yeah. So when we write a program, we use a lot of nested for loops. Yeah. So here the structure very similar. So for the for loops, you have inner for loop, outer for loop. Here, so nested query, we have inner query, outer query. Okay, yeah. Yeah. So we evaluated once. Yeah. So look at the outer query. Outer query for each employee. Yeah. Yeah. Because for the employee table, there are many employees. Okay, many employees. Yeah. Every time we take one employee, okay, for example, one employee. Yeah. All right. So that's in the outer query. Yeah. After we take that, each tuple, we fix it. Yeah. As soon as we select a tuple in the outer query, yeah, so then we fix it, then we get into the inner query. Yeah. All right, so the considering evaluate once for each tuple in the outer, right? Yeah. All right, so we fix the one tuple in the outer query, then we go through all the tuples in the inner, inner query, yeah, inner. Yeah. So here, after you fix SSN, then you run this inner query. Yeah. So inner query, it return a list of ESSN, yeah, yeah, a list, E1, E2, a list of ER, yeah. Then, so your SSN in this list. Yeah. So that structure. But that is this example. We use the in operator. We may have some nested queries without using in operator. So we have other ways to write nested queries. Correlated, yeah. For the nested query, some of the queries not correlated. So this one correlated. Correlated, that is outer query and inner query, there is a correlationship. So the attribute in outer query appears in the data from the inner query. So that's the correlationship, correlated. But some of the no correlationship. That's also possible. So I have outer query, then inner query, you know. Yeah. Yeah. So you do some So sometimes we relatively simple, so there is no correlationship. But for the harder one, correlated a little harder. Yeah. All right, so correlated, yeah. So here, nested, correlated. All right. Then operator, any sum in combined operators. Yeah. So combined, that two operator, you use two operator together, combined. So equal operator and any operator, two together, combined. Equal operator, sum operator, combined together. The meaning is equivalent to in operator. Yeah. And usually we like to use in operator, yeah, because it is very convenient. If we use the in operator, it's very convenient. Yeah. But so usually we do, based on the logic, so we may not like to replace in operator by equal any equal sum. Yeah. But here just let you know, if other people use equal any equal sum, so then when you understand the statement, so you can replace those two operators by this in operator. Then it's easier to understand. All right. Operators other than equal that can be combined with any or some. Yeah, and all. Yeah. Not equal, so greater than, less than. That's also possible, right? Yeah. So greater or equal, less than, less equal, or not equal, combined with any, some, all. Yeah. So in that way, yeah. So you use your logic. Yeah. Yeah. So you can combine this way, and then the meaning is based on the logic. Greater than any. Okay, greater than any. Yeah. So the meaning is obvious, right? Yeah. So the combined operators. So sometimes we need to use these operators to write our queries. Yeah. For example, write our correlated, nested queries. All right. So here there is an example, the salary part. Yeah. So outer query, employee, outer query, then salary greater than all, combined operator, greater than all. Then inner query. Inner query, department 5. Okay, the salary of the department 5, yeah, of those employees in department 5, yeah, but greater than. Yeah. So what are those employees whose salaries are greater than all the employee, the salaries of all the employees in department 5. So this example. Yeah. So this is also nested, correlated, nested queries. Yeah. All right. Next, 8.2. Aggregate functions. So when we write correlated, nested queries, yeah, many times we need to use aggregate functions. Yeah. So we have several aggregate functions that we can use here. Yeah. Summarize information from multiple tuples into a single tuple summary. Yeah. That's the meaning, the reason we use aggregate functions. Yeah. Okay? Yeah. Summarize information. All right. Example. Yeah. So these are the commonly used aggregate functions. Count, count the number of rows, right? Count number of rows in a table. Count function. Yeah. Sum function. Yeah. So sum function will add up the values in a table with respect to a particular column. Yeah. So you need to specify the column, yeah. The numerical values, right? Yeah. So when you apply the sum function, you need to add the numerical values, yeah, but not string values, right? Yeah. It does not make sense. So you call the sum function on string values. So you have to apply it on numerical values. Yeah. Max, min, yeah, max function, min function. Then maximum, minimum. If there is a total order, you can apply max function, min function. Okay, so not necessarily numerical values, right? So when you apply max function, min function, if the field has some total order, then you can apply. Yeah. So for the string values, you can apply max and min. Okay. For date value, date there is order, right? So you can apply max and min. All right. Average, when you calculate average, then you need to apply on numerical values. All right. Yeah. But this aggregate function, yeah. So when you apply these aggregate functions, yeah, there are two ways to apply. Yeah. So here, the next topic, grouping. Yeah. In order to explain this grouping concept, yeah, I need to explain the two ways to apply the aggregate function. Yeah. The first way, you apply the aggregate functions on the whole table. On the whole table. Okay? Yeah. On the whole table. Yeah. Count, so you count the total number of rows in the whole table. Sum, so you apply sum function on this whole table. So that's the first way. But there is a second way. Okay. Sometimes we do another way. Okay? So the second way is like this. Yeah. All right. So given a table, yeah, before we apply these aggregate functions, we divide this table into several subsets, okay, or subgroups. Yeah, so here, because we use the group, subgroups, or groups. Yeah, sometimes people just call it groups, okay, subgroups or groups. Yeah. You divide it into groups. So that's what we call grouping, okay, groups. So group 1, group 2, group 3, and so on. Okay, how to do the grouping? Yeah, later you will see. Yeah, later you will see how to define groups. All right, so you divide the whole table into multiple groups. Then you apply the aggregate functions on each group. Yeah, so here, when you apply the aggregate function on each group, right. So for group G1, you can apply count function, sum function, max, min, average, for example. For G2, then you apply one of the aggregate functions, and so on. For each group, you apply one of the aggregate functions. So that's the second way. Okay? The second way, you need to define all these groups in certain way. So we will see how to define later. Okay? Yeah. But the first way, you do not need to define. Yeah. Because the whole table is treated as one group. One big group. Yeah. So you just apply your aggregate functions on that whole table as one group once. Yeah. All right. Yeah. So grouping. Now let's look at how to define groups. Yeah. Grouping is used to create subgroups of tuples before summarization. Yeah. Before you apply the aggregate functions, you need to define groups in some special way. Yeah. Yeah. Use group by clause. How to define group by? So after group by, you need to specify the way to define groups. Yeah. So let's see how to use the group by clause to define groups. Yeah. Example, a correlated nested query with an aggregate function. Yeah. All right. Question: retrieve the names of all employees who have 2 or more dependents. Yeah. 2 or more. Yeah. Yeah. In our first homework assignment, we just want to, retrieve at least one. Yeah. At least one dependent. Yeah. Yeah. But here, 2 or more. Yeah. So you need, how to get a 2 or more? You need to apply the count function, right? Greater or equal to 2. You apply count function. For each employee, you count the number of dependents. And that counting number, that number should be greater or equal to 2. Yeah. So that's the way. So you write this statement. Yeah. Old way, new way. Okay. The old way, yeah, there is not a unique function. Okay. Yeah. Unique. So you mean, so if there an employee has only, so if a row, yeah, so the meaning of this unique function, if a row appears only once, exactly once, then the unique function returns true. Okay? If a row repeated more than once, then the unique function returns false. Yeah, that's the meaning of the unique function. So here we use the not unique. Yeah. So that means the dependent. So ESSN equals that. Yeah, yeah, because the ESN that equals this SSN more than once. The unique function value not unique. Yeah, so more than once. Yeah. Each time there is one dependent. More than once means at least 2 dependents. That's a unique function. Yeah. Yeah. All right, so that's the older way, yeah, because this older way we do not use the aggregate function, right? We use a special unique function. Yeah. The new way, we use the aggregate function. We count the number of dependents. Yeah. So the new way, yeah. Then in the inner query, yeah, so here where clause, in the where clause we have an inner query. Inner query we call the count function dependent where SSN equals ESSN. So we fix SSN from outer query. So we fix it, okay? Fix SSN from outer query. Then there are several ESN, several possible ESN corresponds to the same SSN from outer query. Yeah. If this employee has multiple dependents, yeah, so the spouse, son, daughter, sometimes multiple sons, multiple daughters, for all those cases. Yeah. So this same SSM may appear more than once. Yeah. But then we count that number, how many times the same SSN appears in that dependent table. Yeah. So that count number, we compare it with 2, greater or equal to 2. Yeah. So in that way, so you can write this query statement. Yeah. Yeah. So here you can see the newer version is better than the older version. Because the newer version, for example, if you change 2 to 3, 2 to 3, okay? So we just change this 2 to 3. So easy, right? But if you use the older way, unique function, then you cannot. You cannot separate 2 and 3 cases, right? Yeah, so much harder. Yeah. So that's the reason the new version is better than that older version. So the version using aggregate function is better than the version not using aggregate function. Yeah. All right. Yeah. But here in this one, in this example, we do not use the grouping, right? Yeah. So the inner query, we apply the count function on that whole table. So we do not divide the table in groups. Yeah. All right. Max and the min function can be applied to a set or multi-set of numerical values. That's the first case, numerical values. Okay. That can also be used with attributes that have non-numeric domains if the domain values have a total order. Yeah, you need to have total order so you can compare. Larger, smaller, you can always compare. Any two values, larger, smaller, for that domain, non-numeric domain. Okay, yeah, string values, data values, and probably other values. Okay, yeah. Yeah, so total order, every two elements can be compared in one of the 3 cases, equal, less than, greater than. That's the total order. Yeah. Another related concept called a partial order. Yeah, but here, because we do not use partial order. Yeah. Yeah. So we do not need to spend time to talk about partial order. Yeah. Partial order, sometimes you can compare, sometimes you cannot compare. That's the partial order. Yeah. But here we assume, here actually most of our domains, we have the total order. Yeah. So we can compare. Yeah, total order and the partial order. Yeah, all right. Yeah, so partial here, I give you some example. Yeah, so the partial order should satisfy the transitivity property. So this is transitive property. If A greater than B and a B greater than C, then A greater than C must be correct. Yeah. But sometimes 2 of the elements, you may not be able to compare 2 elements. Yeah. So there is no order between certain 2 elements. Yeah. That could happen, yeah, for the partial order case. Yeah. Yeah. But in this class, we do not have such examples. Yeah. So that concept, that partial order concept, we can get examples in math and the graph theory, in graph theory. So computer science, graph theory, we have this situation, partial order situation. Yeah. But here in this database class, so we do not have such examples. Yeah. All right. Next, now we need to study that partition for grouping. Yeah. How to define groups. In this 8.3, we need to study the details. Yeah. Partition, yeah? So when we divide a whole table into several groups, that's the partition step. Yeah. All right. Partition concept for grouping. Yeah. Partition concept we borrow from math. In math, we have this partition concept. Yeah. So now we borrow that concept from math set theory, the partition concept. Yeah. So then we use that to understand the grouping concept here. Partition a relation. When we have a relation, we can do partition. Yeah. So here, the relation. Suppose there is a table, we can do partition. Okay. Yeah. Divide it into smaller subsets in a table. All right. From math, partition of a set. In math, we have a concept, partition a set. Given a set, we can break it into subsets. So the way to break it into subsets, so we call it a partition. All right. Yeah. So how to partition a set into subsets? So let's recall the concept in math. Yeah. First, the partition should cover the whole set. So what is a partition? Partition, yeah, the union operator, right? So remember, suppose we have a set called a capital S. Capital S, we want to divide it into union of subsets, okay? Yeah. Subsets Sj, okay? So J equals 1 through n. Yeah. So union, yeah, as the partition. Yeah. So S is the original whole set. Yeah. All right. So now you want to break it into S1, S2, Sn. Yeah. As a partition. Yeah. So the first condition of your partition, so the union of all these subsets should cover the whole original set. Otherwise, it's not a partition. Okay? The whole coverage condition. That's the first condition. Second, yeah, so union of subsets equals the whole set. Second condition, non-overlap. Non-overlap, that means Si intersection with Sj must be an empty set. Empty set. No overlap between any two subsets. Okay, Si, Sj. No overlap. Okay, non-overlapping condition. Second condition. Okay, all right. Intersection of any two sets is empty. Yeah. And non-empty condition. So each one, Si cannot be empty set. Okay? Cannot be empty set. Otherwise, you remove it from your partition. Okay? So none of the subsets can be the empty set. We know the empty set, special set, empty set. None of the subsets in the partition can be the empty set. Yeah. So in order to get a partition in math, you need these three conditions. Condition 1, condition 2, and condition 3. Okay? Yeah. Here we borrow this concept into our database. So when we do the grouping, so we want to have this partition satisfying all these three conditions. All right. Yeah. Then Now, how to do it? So next step, how to define groups. Very simple. Using the attributes, we can define the groups. Partition a relation into non-overlapping groups of tuples. Yeah. All right. How to partition a relation? Each group will consist of the tuples that have the same values of some attributes. Yeah. The attributes, sometimes parentheses, you can use multiple attributes. Single attribute, you can define groups, or you can use multiple attributes to define groups. Yeah. Called a grouping attribute. Yeah. Yeah. So the simple way. Yeah. All right, so let's look at some examples. Yeah. Example. Yeah. Look at this one. Okay. Department number, select department number, count. Yeah. So you apply the aggregate function, count function on, so first you hold a little bit because you need to understand the groups. Yeah. Understand the groups first. Yeah. After you know how to define the groups, then you apply this count function and another average function. Yeah. So then you define groups. So from employee, group by department number. Okay? Group by department number. Yeah. So we know in that employee table, yeah. So this is employee table. There is a column for the DINO, right? Department number. Okay? Yeah. So 3, 4, 3, 2, 5, 1, and so on, right? Yeah. So now you use the department number to define groups. So that means after the divisions of 1, so that's the first group. Yeah. So G1. Okay. Then department 2, group 2, and so on. Okay? Yeah. So you have many groups. So group 6, for example. Right? Yeah. So that's the way you define group. Then for each group, that means for each department. Yeah. Yeah. So for each group, each department, you apply count function and average salary function. Okay. Count. So you count the number of employees in each department. Then you calculate the average salary for all the employees in each department. So that's the meaning. So you can see, yeah. With this understanding, then, so you can, get an idea how to write queries like this. And this idea we can, we can do many queries in this way. Okay? Yeah. All right. Let's look at null value in the grouping attribute. Yeah. So the null value, very special. So when you apply aggregate functions and when you define groups, that null value is treated in a special way. So here there is a rule related to that null function. All right. If nulls exist in the grouping attribute, then a separate group is created for all tuples with a null value in the grouping attribute. Yeah. So we know we use attribute values to divide, to define groups. So each attribute value, we use it to define one group. But when you use values, you may have multiple rows with the null value for that attribute. When that happens, so you do not use each null value to define a group. So you use all null values. So all the rows, all the tuples with null values, you put them in one special group. The group with null values as one special group. Then you apply aggregate function. So that's the rule. Okay? Yeah. So let's look at question. How many employees are supervised by each supervisor? Yeah. We know there are several employees who do not have supervisors, right? So there are 7. Yeah. In our employee table, there are 40 employees. Among the 40 employees, 7 of them do not have the supervisor. That means their supervisor, super underscore SSN, take the null value. Okay, yeah. So here, to write this query statement, how many employees are supervised by each supervisor? Yeah. Each supervisor, we use it's SSN, super underscore SSN, to define a group. But there are 7 tuples whose super underscore SSN equals null. So those 7 tuples we put in one group, one special group here. Okay, all right. Then we apply the count function. Count SSN. Count SSN. Select count SSN from employee group by super underscore SSN. So each group corresponds to one super underscore SSN value. So we do the counting. Okay, all right. Then count SSN. All right. Then return. The value returns the first one 7, because based on the rule, the null value is treated as in one group. So all the tuples with the super underscore SSN, null value is in one group. So that group, we apply the count function, you get a 7, and so on. Yeah. For other, valid SSN number. Yeah. Yeah. All right. Yeah. So that's the null value. Yeah. All right. Join condition in conjunction with group by. Yeah. Join condition. Yeah. Okay. Join 2 tables, then group by. Okay, so you can see we can write more and more complex queries. Yeah. But in our homework assignment number 2, we do the relatively simpler complex queries, and then homework number 3, we practice relatively hard complex queries. So for the complex query part, we split into 2 parts. The first time when we practice, so we practice relatively simpler queries. The second time, so we may practice a little harder complex queries. All right. Question. For each project, retrieve the project number the project name and the number of employees who work on that project. To write this query, so first you need to use the project table, right? Yeah. So project number, project name, the number of employees, and the works on. You need to use works on table, right? So work on, yeah. So at least these two tables, yeah. Here you may not need to use the employee table, right? Yeah, because we only count the number of employees. You do not need to use the employee information, so then you do not need the employee table. But if you need to use the employee information, then you need a third table, employee. Yeah. Here we just use the ESSN to represent employees. ESSN attribute in the works on table. Yeah. All right, so two tables from project table and the works on table. Yeah. P number, comma P name, then apply the count function, the number of employees. Yeah. On that project, look at it. Work on that project. Here, this phrase telling you how to define groups. Yeah. So you use project to define groups. Okay? Project define groups. Yeah. Here, this way. Yeah. So where this is the join condition. Okay? So this is a join condition. You join two tables, the join condition. After the join condition, then you define a group. But here, the way define groups, yeah, so this way. Yeah. Although this way, so here we use two attributes. P number, project number, comma, P name, project name, to define a group. So that means we use these two values to define a group. Yeah. So here actually, so this case, yeah. Yeah. Let's compare with another case. Group by only one attribute, P number. We use the P number value, we can define groups, right? Yeah. So what's the difference? Look at these two ways. What's the difference? Actually, these two ways, we define the same groups. No difference. No difference. Why? Because for each project, there is one P number, right? One project number. And one project name, right? So that's one-to-one correspondence. Project number and the project name, there is one-to-one correspondence between these two attributes. Yeah. So actually it's not necessary because it's a one-to-one correspondence. Why you use the second attribute? Okay? The second attribute does not narrow down. So narrow down. So here, why we use multiple? Yeah. So here, let me explain the general case. Group by V1, V2. Okay? Yeah. So two attributes. So that is usually the first attributes. So when you use V1 value to define groups. Yeah. So group 1, use V1 value. But then you apply the V2 value, you narrow down. So inside V1, then you apply V2 value. okay, to narrow down to smaller groups. So in V1, the larger group, then you split each group in the V1 group, then furthermore using the V2 value to do further split. Yeah, but here, P number, P name, one-to-one correspondence. So after you use P number to split the project, then you use the P name, you cannot split, right? Because one project number, there is only one project number for it. So no further split. So that means your second attribute is useless in this example, okay? So you can only keep the first attribute in this example. Yeah. So when I did grading before, sometimes some students use multiple attributes, but actually you only need one. You do not need it. If there is a one-to-one correspondence, then you do not need to use multiple attributes. One attribute is enough. Yeah. But it's very common. So many students, when they write, grouping attributes, so many times they use redundant attributes. Just like this example. This example, the P name is a redundant attribute because of this one-to-one correspondence. So you do not do further split. The inner split, the second round split, still the same split. All right. Yeah. So I explained that. Yeah. This case, the grouping and the function apply after joining the two relation. Yeah. So you need to join two tables, right? After you join two tables, you get a larger table. Larger table. So many rows, larger tables. Okay? Yeah. Or whatever the table is. Yeah. So larger or small, whatever it is. Yeah. Then you do the grouping within that joint table. Yeah. All right. Same as because this version we remove the second grouping attribute. Redundant, so we remove it. Yeah. 8.4, inner join, outer join. Yes, so this time we need to compare. We need to see the difference. Yeah. The outer join, different concept. Yeah. After you understand the difference, inner join, outer join, sometimes you need to apply the outer join, not inner join. Yeah. So let's look at the difference. Yeah. Inner join, the default. So we're familiar with the inner join. Yeah. So far, all our questions, we use inner join. Okay? Yeah. The default type of join. Yeah. Condition, a tuple is included in the result only if a matching tuple exists. If it does not exist, you do not include. Okay? Yeah. That's the inner join. Yeah. But for outer join, then it's different. So if the matching tuple does not exist, we still include. Yeah. Outer join case. Not null. Exists means not null. Okay? If it's null, then we do not treat as exist. Okay, so the matching tuple, the matching part is null, that means not matching. Okay, no matching. Yeah. Matching means normal values matching, right? Yeah. You match, but based on the normal values. Null value is not a normal value. Okay, so you cannot treat null value as a matching value. Outer join, so now, sometimes we need to include the rows rows whose values are not matched, we want to include. Yeah. So then the outer query type of join. Specify it explicitly. Outer join, yeah, because when you talk about join, you join two tables, right? A table, then join B table. Okay, you have A, you have B. Two operands. This is operator, join operator, then two operands. The first operand A, second operand B. Yeah. So when you talk about outer join, you need to, use specific operands. So A operand is at the left, B operand is at the right. So we have left outer join and the right outer join. These two types of outer join. Yeah. Yeah. Require that all tuples in one table, yeah, A or B, one of the two operands in one table included, even if no matching tuple in the other table exists. So that means your join condition not satisfied. Even if the join condition not satisfied, so you still include the tuple in one of the two tables, either A or B, corresponding to left outer join, right outer join. These two types. Yeah. All right. And the null case because we do not treat null case as the matching. When you compare a value with nulls, we do not treat as a matching one. Okay, all right. Left outer join, right outer join. Left outer join means all tuples in the left table must be included in your query result, even if some of the tuples no matching, you need to include. Yeah. That's the left outer join. Then right outer join, all tuples in the right table must be included, yeah, containing some of the tuples no matching value. Yeah. All right. Yeah. That's the definition. Okay. All right. Yeah. Example using outer join. For each employee, retrieve the employee's last name and the last name of his or her immediate supervisor. Yeah. So employee and the supervisor also last name. Okay. Yeah. Where an employee tuple whose value for super_SN is null is also included. Yeah. Because for some employee, yeah, this part not matching, yeah, not value, not matching, but we still want to include it. Yeah. So let's look at how to write it. Yeah. First, for the table join, employee as E, left outer join employee as S. So the employee copy, E copy, and the supervisor S copy. The E copy, all the SSN for the E copy, we have valid values. But for S copy, yeah, because super_SSN may take null value. Okay, may take null value. All right, yeah. But here when we use the left outer join, we want to include all the employees in the E table. E table. Yeah. So when we apply this matching condition, this is the matching condition. Okay? Yeah. Yeah. Even if this matching condition is not satisfied, but all the employee tuples should be included in the query result. So it's the left outer query. Okay? All right. Yeah. Yeah. So the result. Yeah. Yeah. So you can run this query statement so you can see the result. Okay? Yeah. All right. Yeah. So that's the outer query. Similarly, right outer query. Yeah. You can understand in a similar way. Yeah. Then, after you understand the outer query better, sometimes for some of the query statements, although you cannot clearly see, you need to use outer join. Yeah. But sometimes, if you use outer join, then you can write a query in a very smart way. Yeah. Although from the question statement, it's not very easy to see, you need to use outer join. Yeah. Sometimes you cannot see that clearly. Yeah. But if you use the outer join understanding to write the query statement, yeah. So you can write it in a very efficient way. Yeah. So I will find such example. So I will show you such example. Okay? Yeah. So the null value, actually, yeah, because in that situation, null value is involved. Null value. No matching. When you have no matching, then the null value is used. Okay? Yeah. So when you apply the matching condition, so for the null value case, so no matching, yeah. So then you can use the null value to help you describe some special property. Okay? Some special property. So here you can see the null value is useful. Null value combined with the outer query, so outer join is useful. Okay? Yeah. So although from the question statement you cannot see it. Okay? You cannot see the null value, you cannot see the outer join. Yeah. But the question, you can use that way. Yeah. All right. Yeah. All right. So that's the part A of module 5. So after this part, we can already, so we can practice our homework assignment 2, part B. Yeah, because aggregate function and correlated nested queries, then outer join. Yeah, so we have a lot of things we can practice. Yeah. So this is part A. Yeah. So we will practice 15 query questions in homework assignment 2B. Okay? Yeah. All right, yeah, so let's stop right here. Yeah.